In 1859, a solar storm now called the Carrington event hit Earth so hard that telegraph operators saw sparks jump from their equipment, and some systems kept transmitting messages on induced current alone, with the power disconnected. That was the pre-electric world. The question this video actually answers is, what happens if a storm that size hits the modern grid? 3 real numbers. No disaster movie guesses. Start with what's actually at risk. The backbone of the North American power grid depends on extra high voltage transformers, massive, custom-built machines that step voltage up and down between generation and the transmission network. According to a 2014 Department of Energy study, roughly 2,000 of these transformers exist in the United States. That number is now over a decade old, and here's the uncomfortable part: no more recent official count exists. The agency responsible for the grid's resilience does not have a current, public number for how many single points of failure it's protecting. A severe geomagnetic storm induces powerful currents in long transmission lines, and those currents can overheat and permanently damage exactly these transformers. This isn't speculation. Smaller versions of this have already happened, including a 1989 storm that collapsed Quebec's entire power grid in about 90 seconds. So say a Carrington-Class event knocks out a meaningful fraction of those 2,000 transformers at once. How fast can they be replaced? Here is the second number, and it's the one that turns a bad day into a bad year. Under normal, pre-crisis conditions, a custom extra high voltage transformer takes 18 to 24 months or more to manufacture and deliver, and that's with a functioning global supply chain and no unusual demand. Most of these units aren't kept in spare inventory, because they're too expensive and too specialized to stockpile. If dozens or hundreds failed simultaneously, every utility on the continent would be competing for the same limited manufacturing capacity at once. 18 months, best case, likely far longer once you account for that surge in demand. Now put a dollar figure on the blackout itself. Recent grid risk assessments estimate the total economic impact of a severe geomagnetic storm at somewhere between $0.6 and $2.6 trillion in the United States alone. That is a wide range, and we're not going to pretend otherwise. Modeling a continent-scale blackout that has never actually happened involves real uncertainty. What the range does tell you is the scale. This is not a rounding error. It's trillion-dollar territory, on the low end. 2,000 transformers with no current public count. 18 to 24 plus months to replace even one, under ideal conditions. $0.6 to $2.6 trillion in economic damage if it actually happens. 3 numbers, 3 independent sources, and every one of them says the same thing: the grid was built for a world that assumed this specific event wouldn't happen on its watch. No figure in this video is invented. Where the estimates disagree, we gave you the range, and told you why it's that wide.